Hello, ladies and gentlemen. We are going to be working on lesson 19, comparing data distributions. This is one of the last lessons that we're going to be doing, so it's going to be really important that we understand which data is better, which one is not so good, and why or why not. Looking at example number 1, comparing groups using box plots. It says, recall that a box plot is a visual representation of the 5-number summary. The 5-number summary, remember, is the minimum, the maximum, the median, Q1, Q2, and Q3. Remember, median is also Q2, so I think I just said that twice. And the box part of the box plot is drawn to represent the IQR, and then the 2 whiskers on the outside represent your range, or your minimum on the left and then your maximum on the right. So you have a list of data right here, and it is the data for the 43 participants in the 5-kilometer race. So 43 participants, 5-kilometer race, and it gives you the 5-number summary. Minimum is 18, Q1 is 30, median is 35, Q3 is 41, maximum is 74. Again, we could list these from least to greatest, and we can find all of those on our own. And then when you turn the page, it gives you a different set of data. Now, this data is different. It says this is from a 15-kilometer race, and there are 55 participants. So not only is the race longer, there are more participants, which could affect our data. So we really want to make sure that we're watching out for that. Then it gives us the 2 box plots. Now, you'll notice for this one, it doesn't give us the 5-number summary. It does for the first one, but not for the second one. It goes right into showing us the box plot. So it says, does the longer race appear to attract different runners in terms of age? Here are the below side-by-side looks of the box plot. So it says, do they attract different ones? Well, both their range, and the range is longer because you can see this one's a little bit longer even though the minimum is the same. So range, and you'll notice right here my IQR is longer or bigger, which means there's a higher spread, which means higher variability, which is not what we want. So the range in the IQR for 15-kilometer race is larger. And that means that there's more variability than the short race. Which is not what we want. We want a smaller variability. So then we have these 6 questions based on this. So it says, based on the box plots, estimate the values in the 5-number summary for the age in the 5-kilometer race data set. So this is something that everyone has been struggling with of, well, how can I find all these numbers if it's not accurate? Well, you're estimating. So if I'm estimating Q2 or the median, I'm going to say it's about in the middle. I'm going to say it's about 35. Okay? I'm going to say about my Q1 is about 30. I'm going to say that my Q3 is about 48. My maximum looks like it's about 80. And my minimum looks like it's about 15. Again, I have the data right here. I could find it by putting at least to greatest, but I'm estimating. I'm making sure that it's close. So then I want to transfer that over. So I want to say my minimum is 15. My Q1 is 30. Q2 is 35, Q3 is 48, and then my max is 80. Now it says, do the 2 data sets have the same median? Well, I'm going to look at this, like, let's see what I estimated. So the first one is 35. Oh, mine is 35 too. Yes, they have the same. Roughly. Again, I'm estimating, and that's what it wants. It says estimate the values. It doesn't say to do them accurately. It says estimate. Okay? Do the 2 data sets have the same IQR? If not, which distribution has the greater spread in the middle 50% spread in the middle 50% of its distribution? So middle 50% is this box. Well, we just talked about this. The 15-kilometer race has a larger IQR? I can not only tell that because this one is 41 minus 18 would be my IQR. For my 15-kilometer race, it would be 48 minus 15 IQR. This one's larger, okay? So greater spread, 15 kilometers, and I can definitely calculate that out. 48 minus 15 would give me that answer. Which race had the smaller overall range? So smaller range, that's from the minimum to the maximum. So the max minus the minimum. Which one has the smaller range? Well, we've already talked about it. That, again, this one has a shorter spread for minimum and maximum. So we're talking about that 5-kilometer race. And what do you think the range of ages is for 15-kilometer race? So 5K is smaller. And then 15-kilometer is our 80 minus 15. That's our range. Okay? Whereas this one would be 74 minus 18. Which race has the oldest runner, and about how old was this runner? So 15-kilometer race has the oldest runner, and we said it was about 80 years old. Now consider just the youngest 25%. So again, I'm talking about this much, 25%. 25%. Okay? That's my youngest. Now it says just for the 15-kilometer race, so this one right here. How old was the youngest runner in this group? Well, I said it looked to be about 15. 15 years old. It looked about halfway. How old was the oldest runner in this group? Well, again, I'm going to go to like right about here. It looks to be about 30 years old. How does that compare with the 5-kilometer race? So the 5-kilometer race, their youngest was 18 and their oldest was 30. So this one actually had a younger participant. You can see that right here, that this one's slightly a little bit longer, which would make sense, but these ones are very close to being lined up. Very close. I could even probably make this like 28, 29, because this one even looks a little bit closer. Okay? So what I would like you to do now that we've gone over how to properly compare them, I want you to complete exercises 7 through 12. You're going to get 7 through 12 checked. Then you're going to grab your 2-page exit ticket. After you finish that, you're going to staple it, turn it in, and then you're going to do both problems on the homework. All right, go ahead and get started.